In this lecture, we're going to understand why system design has become such a critical skill for the developers, especially in the current market. Now, you might be thinking, I already know how to code. I can build the applications. So why do I need to learn system design? That's a valid question, and I want to address it properly. The thing is, the coding and the system design are two different skills. Coding is about how to implement something, but system design is about what to implement and why. Let's say, for example, you're building a social media application. You know how to write the code for the user registration, posting the content, adding the comments. All of that is fine. But here's where it gets interesting. When your application grows from 100 users to 1,000,000 users, the same code that worked perfectly before suddenly starts failing. Why does this happen? Because the design of your system wasn't prepared for this scale. Suppose you stored all the user posts in a single database table. With 100 users posting maybe 10 times a day, that's just 1,000 posts. The database handles it easily. But with 1,000,000 users, even if they post just once a day, that's 1,000,000 posts daily. After a month, you have 30 million posts in one table. Now every query becomes slow. The database struggles, and the users complain about the loading times. This is not a coding problem, it's a system design problem. And here's something interesting about the current job market. Companies have realized that with the AI tools like the ChatGPT, anyone can generate the code these days. You type what you want, and the AI writes the function for you. But the AI cannot decide your system architecture. It cannot tell you when to use the SQL versus the NoSQL, when to implement the caching, or how to handle the data consistency. These decisions require the understanding of the trade-offs, the business requirements, and the cost implications. And that's exactly what makes the system design skills so valuable. Now, I want to share something about how the interviews have changed. Earlier, most technical interviews focused on the data structures and the algorithms. You know, reverse a linked list, find the shortest path. Those kinds of problems. But nowadays, especially for the senior positions, companies are asking the system design questions. They want to know, can you design a chat application like the WhatsApp? Can you build a video streaming platform like the YouTube? And they're not asking for the code, they're asking for the architecture. How would you handle the millions of concurrent users? How would you ensure the messages are delivered reliably? These questions test your ability to think at a higher level, beyond just writing the functions and the classes. Let me tell you about the career growth aspect as well. As a junior developer, you mostly write the code based on the specifications given to you. Someone else has already decided the architecture. You just implement it. But to become a senior developer or a tech lead, you need to make those architectural decisions yourself. The product manager comes with a requirement, and you need to figure out the best way to build it. For instance, they say, we need to add a notification system. Now you have to think, Should the notifications be real-time, or can they be delayed? Should we use the WebSockets or the polling? How do we handle the users who are offline? These are the questions that separate the senior developers from the junior ones. And honestly, this is also where the big salary differences come from. A developer who can only code might earn a decent salary, but a developer who can architect systems, they're in a different league altogether. We're talking about double or even triple the compensation, because these skills are rare and valuable. Now you might wonder, what exactly are we going to learn in this course? We'll start with the fundamental concepts, understanding what makes a system scalable, what makes it reliable. We'll learn about the different components, like the databases, the caches, the message queues, and when to use each one. Then we'll dive into the real-world case studies. We'll analyze how the companies like the Instagram handle the billions of photos, how the Uber matches the drivers with the riders in real time. And most importantly, we'll learn to think in terms of the trade-offs. Because in the system design, there's rarely a perfect solution. It's always about choosing the right trade-offs for your specific situation. So to summarize, the system design is important because it's the skill that the AI cannot replace. It's what the companies are looking for in the senior developers, and it's essential for the career growth. Whether you're preparing for the interviews or want to build the better systems at work, this knowledge will transform how you think about the software development. All right, that's our introduction to why the system design matters. In the next lecture, we're going to learn how to think like a system architect.